Alright, so today we are going to be learning how to identify different kinds of triangles based on the length of their sides and the relationship between the sides. So, if we have this triangle, for example, what we call this kind of triangle is an isosceles triangle. So, an isosceles triangle means that two of the sides are the same and one's different. Now, there could be, we could measure this to determine that, or sometimes if we don't know how long the sides are, what you'll see is these little tick marks like this. And what that means is that if two sides have the same amount of tick marks, that means they're the same length. So in this one, you can see that these two sides are the same length, and this one is the one that's different, because this has one tick mark each, and this one has two. So the second kind of triangle there is called equilateral. Can anyone guess what an equilateral triangle might look like? Yes.
Does it have all equal sides?
Exactly. So an equilateral triangle might look something like this. Now if there's one tick mark on this one, how many tick marks are we going to put on this one?
One.
Perfect. And for the last one?
One.
Exactly. Now the last kind of triangle we have based on length here is what we call a scalene. Now, does anyone have any idea what a scalene triangle might look like?
Are all the sides different?
Yes, exactly. So an example of a scalene triangle might look something like this. So if this one has one, how many tick marks are we going to put on this long one here?
Two.
Exactly. And then this last one?
3.
Perfect. Because since none of these lengths are the same, none of the sides are going to have the same amount of tick marks. Alright, so now that we've sort of identified the three different kinds, I'm going to have us build our own and identify our own. And we're going to do that not with tick marks now, but with actual measurements, because we have rulers and things like that, so that we can actually put numbers in here rather than just tick marks. So, if we have a triangle like this one here, the first step in identifying it is going to be to measure the sides. So if I really quickly measure them here, I have my first side is 8. So I'm going to put side A as 8 sides. Then I'm going to look at this bottom side here, where I see it has 5. So I'm going to put 5 in here. And then our last side, if I measure it here, it's 10. And this is in inches. Alright? So now if we're looking at this triangle, we have 8, 5, and 10. The next step is going to be identifying how many of those sides are the same. So if we look at these are my sides. How many sides are the same?
None of them.
Exactly. 0. Now if we reference over here, which one, now we can do our step 3, which is identify the triangle. And if there are 0 sides are the same, which kind of triangle is that?
Scalene.
Perfect. Alright, so now in front of you all, you have pieces of paper that are all, strips of paper that are all different lengths, and a ruler. And what I want you to do is partner up with someone next to you, and I want you to, one of you to build the triangle, and then the other person to measure it, identify the number of sides that are the same, and then finally, using this, identify what that triangle is. So, go for it. Okay. Those look lovely. Alright, so now what I want you to do, now that you've created your triangles and identified them, does anyone want to volunteer to share with the class the steps you took to identify your triangle? Andy!
Okay, well, our triangle has one side with 4 inches,
Alright, so side A has 4.
side B has 4 inches, and side C has 2 inches. So we have 2 congruent sides, and that means that it is a isosceles triangle.
Excellent, that was perfect. Alright, does anyone else want to share theirs?
Sure.
Alright, so step 1, measurements. What were your measurements?
We had one side that was 4 inches,
4.
one side that was 5 inches, and one side that was 2 inches.
Alright. And then step 2.
They had 0 congruent sides,
Alright.
so it must have been scaling.
Perfect. Does anyone have any questions? No? So to very briefly go over what we've learned today, a really easy way of identifying different types of triangles is by looking at the length of their sides, and not just that, but also the relationship each side has with each other. So if we have a scalene triangle, how many sides are the same?
0.
Yes. And an isosceles triangle?
2.
2.
And the last one, equilateral.
3.
And if I have a triangle that has 2 similar sides, what kind of side?
Isosceles.
If they're all the same?
Equilateral.
And if they're all different?
Scaling.
Perfect. All right.